Hello, good day to everyone. This is Sir Myron. This is my first educational blog in teaching science. What will be discussed today is all about atoms. Atoms or atom. It's structural framework. Okay, so this chapter helps us understand the development of the atomic structure since the time of John Dalton. The concept of atom has continually changed and will still change in the near future. So guys, this is just a um, information comes from the internet, experience, and some of the books I've got, and also some jotted down from my colleagues and superiors. Okay, so let's get started. Okay, this chapter discusses why and how. So why and how. Why and how elements differ according to the similarities. Differ according to similarities in properties and how their atomic structure can be related with such things such as light at home, appliances, and multivariate colors of fireworks or explosive. Okay, so let's get started. First is we'll be discussing the nature of an atom. So John Dalton or Dalton. Dalton's atomic theory. So Dalton's atomic theory explained the indivisibility of atom, wherein when the matter reached its limitation, dividing it until the matter reached the point where you cannot divide it. Okay. Um, Two philosophers like Democritus and Leucippus called it as atom. Okay. So wait, let's have next one. Next paper. Okay. So he said that an atom cannot be subdivided. Okay, so atoms or atom cannot be subdivided, and it is the basic or the smallest particle of a matter is made up. So this is the atom is the smallest particle, okay, that the matter is made of. Many particles smaller than atoms have been described by physicists. Okay, so of course this is called as subatomic particles. So smaller than atoms are its subatomic particles. Okay, so the names of subatomic particles are proton, neutron, and electron. So atoms of different elements vary from one another in the number and arrangement of these three subatomic particles. So let's have a drawing or illustration shows that an atom is a subdivided particle of a molecule or matter that makes up a piece of matter. So let us draw first. So let's say this is the pencil. Okay, so we drew pencil. Wait, let me just draw something here. So this represents, okay, we're dividing matter here. Okay, so this represents the illustrations or illustration shows us that an atom is a subdivided particle of a molecule that makes up a matter. So this is the atom. Okay, combining it or reversing this, forming a bigger particle which is molecule. And these molecules, okay, if this is grouped together, will become bigger particle, which is what they call matter. Okay, so as you can see, so it shows how matter is being divided into to its smallest part, which is the atom here. Okay, let us have another example. Okay, I'll just erase this. Okay, so let us have first the water. So let us draw water, or sige. Okay, so this is the water. So let's have an example. What as matter, of course, which is if we'll be having it a smaller parts, smaller part will become H2O. As molecule. And for the last one is its atom. Okay, so I hope you understand the illustration that shows how matter um, is being divided. Okay, and reach its smallest part, which is the atom. So next is the origin of atom. So the word atom comes from the Greek word atomos, which means uncut. Okay, so this ultimate particle of matter may be described as the smallest neutral, relatively stable fragment of which matter can be broken down into. Okay, relatively stable fragment of which matter can be broken down into. Okay, so let's proceed to the next. So I'll just erase this. Okay, so let us proceed. So atoms are not solid particles. They're mostly space. So not atoms are not solid particles. They're mostly space. Almost all atomic nuclei, except that of hydrogen, contain unchanged unchanged particles called neutrons. The number of positively charged protons. Anyway, we've discussed protons. What is the charge of protons? They have positively or they are positively charged or positive charge. They have positive charge. Okay, the nuclei and the number of negatively charged electrons are equal, so that as a whole, the atom is neutral. So did you get the point? We're in the number of positively charged proton here and the number of electrons negatively charged, negatively charged, negatively charged electrons are equal, so that as a whole, the atom is neutral. So it means that all atoms are neutral because they contain same amount or same number of protons and electrons inside it. Okay, so let's go to the next, which is the contributory scientists. Oops. Okay, many of the early experts in science thought of searching for ultimate particle of which matter is built. Thales of Miletus near 634 to 546 BC proposed that all things came from one prime material, which is the water. Okay, next is Empedocles or Empedocles. MP, wow. Empedocles or Empedocles, year 490 to 430 BC, a Greek philosopher. Okay, proposed that matter is made up of four elements, which are earth, water, air, and fire. Okay, so before I continue, I'm going to erase this, the upper part here. Okay, so let's continue. So Democritus year 460 to 370 BC. Okay, another Greek philosopher. Okay, another Greek philosopher. Excuse me. Developed a theory of atoms. So he developed the theory of atom. He said that matter is made up of tiny invisible atoms. So he quoted this. He said this matter is made up of tiny invisible atom or atoms rather. Next is, or lastly, Aristotle, year 384 to 322 BC, also a Greek philosopher. A Greek philosopher rejected Democritus. I later challenged Democritus about his proposed theory, wherein he rejected it. Okay, rejected Democritus' theory. Theory. Okay, Democritus' idea or theory, and claimed that the matter could be subdivided into minute particles. So let's repeat it. Matter could be divided or could be wait, subdivided but into minute particles. Okay, so next let's proceed now to development of the atomic theory. So let us erase this first. Okay, so the development of the atomic theory. Okay, so let us have first illustration before we keep the theory of every scientists. So let us have this first illustration. So John Dalton, John Dalton, year 1766 to 1844, an English chemist. And physicist. Okay, he revived the idea first proposed by Democritus, wherein he pictured an atom as tiny, indivisible, or indestructible sphere, okay, and endowed it with mass. So here's what it looks like. Let me just change this to sphere. Okay. Does it look like sphere now? Okay. So next is Joseph John Thomson, or J.J. Thomson, year 1856 to 1940, an English physicist Physicists saw an atom as a positive sphere with negative electrons stuck in it, like raisins in a loaf of bread. So if you if you have seen a loaf of bread with raisins, I think that's randomly distributed from different parts. So let us have first positive, negatively charged here. Picture out what he was trying to say. Okay, so this was the same thing, I guess. Okay, so this is what it looks like. Next, we have another illustration here coming from Ernest Rutherford.
Oo, may saksakan nga doon ah. Ilalagyan lang nila yung namin yung saksakan ng bus. Talaga.
Okay, so I guess this is it. So let us have Ernest Rutherford.
Dapat siya, hindi mo muna. Ganun, ganito.
In year 1871 to 1937. So his model is known as the nuclear model of atom, wherein he said that an atom is mostly empty space. Here, let me just write add sign here. He said that an atom is mostly empty space and that has a tiny positive core nucleus. Okay, in the middle here, which are positive, they are all positive. What the? Okay, so positive core nucleus and electrons with smaller spheres revolving around the nucleus. So it means it is moving. They are moving. Okay, so that was said by Mr. Ernest Rutherford. Next, so let us first erase this. Excuse me. What? Okay, so let us have the next one. This coming from Mr. Niels Bohr. So we have proton and neutron inside. Wait, let me just first um, curve curve the lines. Okay. Okay, so I think this will do. So we have P and N here. Okay, so this was from Niels Bohr, year 1913. Wow, good writing. The Danish nuclear and theoretical physicist, he saw that the atom as a miniature solar system with its nucleus at the sun, as the sun and the electrons whirling around it. As the planets that orbit around the sun, he said that the electrons are arranged around the nucleus, called energy levels or shell. So he said that electrons, let me write that down, electrons are arranged around the nucleus, called energy shells. And lastly, for the development of atomic theory, we have Mr. Arnold Sommerfeld. Okay, that's okay. So Arnold Sommerfeld, not Summerfield. Correction. He modified Bohr's he modified Bohr's theory or model of atom by then adding the now accepted elliptical orbits to explain certain experimental data. Okay, so I think that's enough for our development of atomic theory. So let us proceed to the next. So let's go back to the word atom. This is the smallest part, as we're discussing, smallest part of an element that can take part in a chemical reaction is described as an atom. This consists of small, dense nucleus made up of okay, neutrons with a negatively charged in a cloud around its nucleus, which is the electrons. Okay, so one of the powerful machine used to study the composition of atoms is what we call synchrotron. That was before, I don't know. There's so many new developed machines which are now used to observe atom. Okay, so let us first write this one. Synchrotron is a huge machine used to observe or study the composition of atoms. Okay, so let's now go to the parts of atom, which is the illustration. So let's create two circle Let's have P and N inside. P has negatively charged and no charge. And outside, which is roaming around, we have what they call proton. Here, neutron. And lastly, electron. This is the parts of an atom. Okay, so the whole atom has no charge. Let me just erase this first. So the whole atom has no charge because there are so many protons as there are electrons, so they have same numbers inside it. So the charges balance each other out. So although protons and electrons have opposite charges, protons or proton positive does not attract electron negative right into the nucleus because of speed. The electrons keep them flying off away. So electrons at its speed keep off away. Keep off them flying off away. Okay, flying away from the nucleus. The pull of the nucleus keeps these electrons in their orbit so that atom does not lose them also. So there is attraction, but okay, this is just enough for not losing the electron. Okay, so let us proceed to the next. Okay, so that's it for today. We'll be discussing the parts of atoms for the next day or this week. Okay, I hope you like this video, and if this is helpful, you may share it with your classmates or friends. Okay, thank you for listening and watching the video. This is Sir Myron for Teaching Science.